This is one question from the chapter application of derivative, which is based on maxima minima concept. It says of all the closed cylindrical right circular can of a given volume. That means the volume is fixed here, which is 100. I can see here centimeter cube, and we have to find the dimension. Dimension by default has to be the radius and height of a cylinder, which has the minimum surface area. That means surface area, which is total surface area, has to be minimized here. Now, let's say if I draw a cylinder, let's say if I draw a cylinder here, all right, this is the cylinder, and this is the height, and this being the base radius. So let's set this aside. Now here, volume is fixed, and we know that the volume of a cylinder is pi r square h, and volume is mentioned as 100, which is 100 pi r. 100 is equal to pi r square h. Now let's figure out, we have to minimize the surface area. So we'll find the derivative of the surface area. So surface area by default has to be the total surface area, which is curved surface area plus area of two bases, which is 2 pi r square. Now I can see that we have two variables and need some substitution. Now I can see that the substitution is possible with h. That means I can isolate h here and write h as 100 over pi r square. So this is s into 2 pi r, replacing h with 100 over pi r square plus 2 pi r square. Further, I can see that not 2, r square with 1 r get cancelled and pi with pi get cancelled. We are left with s is equal to 100 into 2, that is 200 over r plus this is 2 pi r square. Let's find its derivative. If I find its derivative, it's ds by dr. That's coefficient 200. The derivative of 1 by r is minus 1 by r square. And the derivative of this is going to be 4 pi r. Now let's also find out its second order derivative has to be d square s by dr square. So derivative of 1 by r square, let's figure out. I can write this as r raised to the power minus 2. So it's minus 2 r raised to the power minus 3. So if I multiply this, or I can further write this is minus 2 over r cube. So that means this minus will become plus, and when multiplied by 2, or I should show you, this is 2 by r cube times of minus 200. And for this, it is going to be just 4 pi. 4 pi. So I can simplify it further, and this is going to be how much? 400. So I can write it directly positive 400 by r cube. So I should show it. This is 400 positive by r cube plus 4 pi. Now this is what we got its second order derivative. And now we will equate the first order derivative with 0 for maxima or minima. This ds by dr should be equated with 0. That is this one. On equating with 0 and transposing simultaneously, I can see we are getting 4 pi r is equal to, on the other side, it will be positive 200 pi r square. So this can be reduced with 50 times. So that means r square into r is r cube is equal to 50 over pi, or I can say that is r is equal to 50 over pi raised to the power 1 by 3. So we got this, and we need to show that the second derivative test that at this point d square s by dr square, we have to minimize, so it has to be greater than 0. And that's possible also. You can see that replacing r being a positive and pi 4, they are all positive terms. So we can say it is going to be greater than 0, hence hence maxima at this point. So once we got r, now we have to get h. This is what we got r here. We have to find the dimension. As I said earlier also, we have to find the dimension. And the dimensions, one is this, another we need to find out. That is the height. Let's say I can replace here, right? The substitution is this. So this is 100 over replacing r with this value. That means it's going to be 50 over pi raised to the power 2 over 3, because this is 1 by 3 and this is square. So that is 2 by 3. And we can simplify it further. So if I write 100 as 2 into 50, and this is pi, and I can write its denominator pi as pi raised to the power 2 by 3 over 50 raised to the power 2 by 3. So we get h as, so this 20, these are 1 minus 2 by 3, applying laws of exponent. We'll get 50 raised to the power 1 by 3, and pi also raised to the power 1 by 3. So it's 2 into 50 over pi raised to the power 1 by 3. So this will be the other dimension, that is the height.